Hi, welcome to Provoke Your Physics channel. Today we are going to discuss about the cells, that is in the electric cell. How when the cells are connected in series and also the parallel, how its internal resistance will be changing, how the current will be delivered from the battery will be affected, and which would be the best combination of a cell, whether it should be connected in series or parallel. Of course, it depends on the situation, how we can find. Yeah, from the diagram you could understand. See, E is the EMF of all the each cell and small r is the internal resistance of each cell. Now capital R is the external resistance I have connected. The R would be any load. So here we have n number of cells will be connected in series. Each cell will have an EMF E and the internal resistance R. Okay, now it is being connected with an external resistance capital R. Now in this case, what would be the total resistance? The total resistance when these are all connected in series, so n times of R, okay, and it is being connected with this external resistance, so that is nr plus R. Okay, this will be the R effective. R effective means the total resistance offered by the cell combination. Right now I am going to find what would be the current flows through these. Okay, current can be delivered from this setup. So we know that I is equal to V divided by R. So I effective will be equal to the total EMF. Actually, what is the total EMF? Each cell will have an EMF of E. So when we have n number of cells, okay, I can have n times of E divided by the total resistance, that is R effective. So I can say n number of E, n times of E divided by n of R plus capital R. Okay, this will be the total current. This will be the total current when the cells are connected in series. Okay, right. Now there will be two options are there. Okay, so the internal resistance of the cell, that is the combination of the internal resistance of the cell may be greater than the external resistance or smaller than the internal resistance. Okay, so what is the benefit? First, let us discuss when small r much greater than capital R. Small r will be much greater than capital R. So when small r is much greater than capital R, then n of R will be much greater than capital R. So I can neglect this R in this equation. So I will get I effective will be equal to, okay, n times of E divided by n times of R. So this is nothing but E divided by R. This is nothing but I1. That means the current which will be delivered when the internal resistance will be much greater than the external resistance. Okay, the total current, however, or how many number of cells will be connected in series, we will be able to get only the current which can be delivered by the single cell. Do you think it is advantage? Never. Okay, it is not good for the connection. Now let us discuss when R will be much smaller than capital R. That means, okay, the resistance will be external resistance which will be much greater than the internal resistance. So obviously n of R will be, okay, much lesser than capital R. Okay, so this equation will become I effective will become, okay, n of E divided by R. So this will be equal to n times of I. You guess. Okay, this will be the best combination. Okay, because here the effective resistance will be, okay, the n times of all the individual cells. So we can have more current in this combination, in this setup. So when the cells are connected in series, we have to prefer this one. Similarly, what may happen when the cells are connected in parallel? Let us check. See in this diagram, okay, we have connected n number of cells in parallel and it is being connected with an external resistance. Even I am going to use the same formula, that is, okay, our aim is to measure what would be the current can be delivered from this. Okay, for that I have to measure what would be its total resistance. See, all these internal resistance will be treated as connected in parallel. So n number of internal resistance also available. N number of equal resistance are connected in parallel. The effective resistance will be, we have the formula, that is R divided by N. Okay. If it is so, the total resistance, the internal effective resistance will be equal to R divided by N. The total resistance will be, R effective will be equal to R by N plus capital R. R by N plus capital R. Okay. So why? Because it is being connected with the series. Okay. This will be the total resistance. Now I am going to find what would be the I effective. Okay. I effective will be equal to, okay, total EMF. What is the total EMF? When the cells are connected in parallel, we know that in a parallel combination, the potential is constant. Okay. So the total or the EMF can be delivered when it is connected in parallel. I can have only E. That is the EMF of any one of the cell. Okay. So divided by R divided by N plus R. Suppose if I take an LCM and rearrange this equation, I will get, okay, this will be equal to N times of E divided by R plus N times of capital R. N times of capital R. Now once again, I am going to use the same strategy. What may happen when R will be, okay, R will be much greater than capital R and R will be much smaller than capital R. Okay, these are other two options we are going to discuss. Okay, right. See, when the internal resistance small r, okay, much greater than capital R. Okay, now what may happen? Okay, n of r will be, okay, much smaller than capital R. So I can neglect this n of r. Now I have the formula, I effective will be is equal to n of E divided by R plus n of R. So I can have I will be equal to n of E divided by R. So this will be equal to n times of I. So I can have maximum amount of current when the internal resistance will be greater than the external resistance. So in this case, when we are connected the cells in parallel, okay, even though when the internal resistance will be greater, no problem, we can have maximum amount of current. Thus parallelly, if the internal resistance will be much smaller than capital R, okay, once again I am substituting the formula value here, I will get, okay, that is n of R will be much greater than R. I can neglect this small r, so I will get I effective will be equal to, okay, n of E divided by n of R, so which will be equal to I. So this combination, it won't give any advantage to me. So I have to prefer when the cells are connected in parallel, okay, it must have the internal resistance should be greater than the external resistance. Thank you. Okay, by this combination we can understand how the cells has to be connected. Depend on the situation, okay, it can be taken whether it should be connected in series or parallel. Okay, so here the internal resistance is taking very important role. Thank you. If you like this video, please like, share and subscribe. Thank you.